me for the hidden gems of distributed tracing. We're going to look at some scenarios today, and I hope you'll have some more questions for me after seeing the scenarios of today. A little bit about myself. I am Anna. You can find me on Twitter at Ambra with 2 M's 1508. I was told that this is kind of an interesting alias, but yeah, this is my handler. This is where I'm publishing different articles that I'm writing or workshops that I'm contributing to. Is the mic not? Okay. Is it better? Oh, it's because of the mic. I'm sorry. Thank you. It's the mic. Now it should be better, I think. Yeah. Thank you very much. So yes, you can find me. You can find me on Twitter at this handler. I'm a Java champion and certified architect, and I'm currently working as a developer advocate for Red Hat. I'm also contributing to tutorials and to different workshops that Red Hat developers we are doing in Red Hat as Red Hat developers. And well, as is said in the slide, I'm really passionate about scenarios that are a little bit more complex, that are around using Java, and of course using Kubernetes and other cloud providers. So yes, this is pretty much my focus area. So when we moved from, let's say, I like to call it the vintage approach to the modernized approach, when it comes to working with this new kind of distributed applications, always in the beginning looked very nice and cozy. The thing is that when we were working on monoliths, we were able to follow a transaction as it was in a single application, so we could really easily, we could identify what was going on with the request in, let's say, much easier fashion. However, with the modern approach, one challenge that is coming is to understand how your request has traveled across multiple services, what happened with it, and of course, if something wrong has happened to it at some point in time, to troubleshoot that issue. So, the story of today, of course, starts with once upon a time, something unexpected occurred. And it is not always something that is visible, and maybe it's not even bothering us that it's happened, so we can go ahead with it. But what happens is that tools record this disturbance in the flow of requests. And with this when this disturbance is happening, you'll get some logs, and of course you get some metrics. If it happens one time, you can say, yes, I'm happy. It happened just one time, it will not happen to me ever again. However, if it happens a couple of times, there are logs, and of course there are metrics. In the ideal scenario, where you're keeping an eye on your system and you're observing your system really, really well, you would see that disturbance and it will trigger some impact. Well, you would see the impact when you're measuring things on your service level objectives, because nowadays we're kind of working, stepping towards service level objectives, not necessarily to SLAs, because SLOs can be incorporated in the tools that we're using, so it's much easier to measure things and to tailor things than just saying some SLAs and some percentages over there. Now, once this has happened, we have some logs, we have some impact about what's happened, we can go further and say that maybe this won't happen anymore. However, there might be issues in disguise. And in time, those are impacting the overall SLOs. I would say that you can see the impact maybe at the end of the year when you're looking to the quality of the service that you offered. So then you're assessing yeah, it was not 999.99995 something. It was missed because of certain things. However, when it comes to troubleshooting, distributed tracing can help us, and can help us in also correlating what has happened with that certain transaction, but it can also help us to correlate this with the metrics that we're actually looking into, maybe in Prometheus, or maybe we have some dashboards in Grafana. But let's say distributed tracing is offering us answers about which service calls were involved in the normal transaction. So that's where it can help us, by the way. What were the versions of those services that were involved, that were traversed by those requests? Because maybe you have different versions at some point in time. You deploy your applications multiple times, let's say in a month or in a year. And you can make some observations based on when this happened, why this happened, and what was the differences between the services. Maybe in one service version this wasn't occurring, in others it did occur. And of course, were there any exceptions recorded? This is very important. When it comes to distributed tracing, recording exceptions is mandatory. Otherwise, you might end up with swallowing things and not knowing that something bad has happened. So this is our thing. There are three main areas where distributed tracing can offer answers to us. But if we're looking into an example, in context tracing, in context tracking of a transaction from endpoint to endpoint, in this case, and you can observe it. The trace ID, it's starting somewhere with one service. Then the context is going through green, let's say green microservice, and can traverse also other microservices as well. How this translates into traces, spans, attributes, and exceptions is as follows. So I just kept, for the sake of it, the same color so that you would understand the parallel. When going from green to, goes to green, everything, then some spans or some information, some attributes are added to the current span in the blue one. And of course, maybe an exception gets recorded in the yellow one. You can also follow this with a single trace. So you are keeping an eye all together when you're using tracing. Furthermore, in order to help us with tracing in time, there were different specifications. One of them was open tracing. I pretty much worked with open tracing and open census. However, when it comes to migrating from open tracing to open census from using certain tools, it was a little bit more complex. And this is why OpenTelemetry was invented, I would say, which is a project that unites both specifications so that when we're trying to migrate things, when we use open tracing, for example, or when we are used more to open tracing to use tools that are more aligned with open census to have this alignment together. So OpenTelemetry is combining the best of the both and even more. So OpenTelemetry is coming with two parts. One is the specification itself. And for it, you have SDK implementations that are for different languages, Java being one of those. There's an API for the application developers. And of course, there's data that you can collect with OpenTelemetry Line Protocol, OTLP, and some vendor-agnostic semantic conventions. What you'll find that different vendors are doing is that they are actually aligning to this API for the developer scope, that they're aligning with the OTLP, with the protocol, so that you don't have issues when you're trying to migrate or maintain such an implementation. And yes, there are SDK implementations and a lot of contributions happening. And for the moment, OpenTelemetry, I think, yes, OpenTelemetry is not yet, let's say, matured to 1.0, but is expected to mature to 1.0 soon. Now, the most important part when it comes to OpenTelemetry, I would say, is the collector, because that is something that we see as developers that is helping us. And the collector is having several parts. There are the receivers, where data can be pushed or pulled, processors, where data, how to handle the data received, and of course exporters to which received data is sent to. Receivers, processors, and exporters can be tools. What the collector is doing is uniting and unifying all these tools via a nice specification so that we don't end up putting everything into bits and places, and then we're wondering how we connect everything together. But then there's coming a question. Okay, we're using this nice implementation, nice specification, and we're asking ourselves how much tracing data is enough. Because if you're tracing everything, I mean, you're recording everything about your microservice in production, you will end up with a lot of data that might be not necessarily needed for you to know all the time or to have all the time. And this data is actually also consuming some resources. So how much tracing data is enough is a question that has come to the mind of people that were working with distributed tracing for some time. Like, how can we tailor this even better so we get only what we need and not get things that are, I don't know, not needed, and like spend a lot of time mining this data to like understand what's going on there. So ways to avoid oversampling, because sampling is the technique what we're using when we're trying to get information about our distributed transactions. And oversampling is, as the name is saying, the way that your transaction, you get too much information. The way to avoid oversampling, I would say that they are like three solutions from my point of view at least. One of them is that you're using the requests for debug using a special HTTP header. What I'm trying to say here is that when you try to trace something that's not going on well with your service, it's better to have a special HTTP header because you can exclude those requests from your dashboards that are actually measuring the performance of your service so that you don't end up adding more to something that's already failing. That's actually impacting your service level objectives and how you get to those percentages so that you don't end up with, I don't know, too much information that maybe it helped you to debug something, but it's making the worst case when the, let's say, business folks are going to look to the numbers and are going to say like, oh my God, so many failures. We're going to look at this tracing of using a special HTTP header because the code has one of these. Then we can define different sampling strategies per application profile. One thing that you can do, when you're in development mode, because that's development, you can sample 100% your requests. That's not a problem. Because you're in development mode, it can help you to like test different things, different scenarios. But if you're going to the upper environments, you should consider coordinating these strategies when you're going there. Because, well, you might not need 100% for the upper ones. Again, you're getting too much data. And last but not least, you can use configure tail-based sampling in processors of OpenTelemetry. So what means tail-based sampling is like you're sampling with a call at the end of the request of the execution. So you decide if you want to keep the trace or not. And that's a very powerful thing. You should decide what you want to keep because you should keep only what's needed, right? So, and there are ways to do that. There are some policies. I'm going to show them in the code as well, but this is just an extract. And there are some examples of policies for tail-based sampling. So one of them is like a sampling policy based on latency. So sample based on the duration of a trace. You can like look at how the duration of your traces for some time and think about, let's say, what would be the threshold in the milliseconds and establish that and sample only those. So this is one type of policy. Next one, you can sample based on error codes. So you can even do that based on status codes that your application is using. So for example, if you have, I don't know, services that you know that at some point they can throw some error codes, you can do that and trace only on those status codes. This is very efficient from the point of view like you want to capture only errors and you don't want to capture things that maybe they're not of interest to you. And maybe one of the most powerful things with OpenTelemetry is the fact that you can have composite policies. So these composite sampling policies are very nice because you can combine this one with the latency sampling, with the status code, and you can do that for each of your services. And you can like configure also the max total spans per second and many, many more. And you can also put the order. So the order for your policies, how they should be considered and why when sampling based on that. Okay, now's the demo time. I think that's much more interesting. Now the demo system context. Sorry, hope they can see this. We're going to have two microservices. The first one is called Hobby. It contains some front end. The context would go through it. Then another one called activity that consumes an external API. So pretty much like in the blue, green, yellow picture seen earlier, our span, our trace will travel through hobby first, will go through activity, some attributes will be set, some exceptions can be recorded in some cases, and of course afterwards we'll go to the external API. That's not managed by us, so yeah. I'm using Quarkus in this implementation. So there are a few things that you need to add when you want to work with Quarkus in OpenTelemetry that are there to help you with these. So you can use the Quarkus OpenTelemetry extension, but because I'm using Jaeger, I have used the OpenTelemetry exporter Jaeger because I want to export to Jaeger, and that's how I'm going to put my exporter. Then I want to trace those. I need to add the OpenTelemetry extension for tracing propagators so that I can connect my Jaeger to OpenTelemetry collector. And then I can use the Quarkus micrometer registry Prometheus to have Prometheus where I'm exporting my metrics. And I also use the Quarkus Morai Health because I will export also the metrics related, I will export also the endpoints for my health. Another good practice is that I've observed is that it's good to know how your health endpoints behaved at some point in time, and to also trace those because they can give you information of how many times your application restarted, what was the cause of that, and you can also trace those endpoints too. Then, of course, you get the traces in Jaeger. So the receiver and the exporter in the OpenTelemetry collector configuration is set to Jaeger. And of course, countdown is going to be exporter in the OpenTelemetry collector configuration into Prometheus. So as explained earlier with OpenTelemetry, the collector has the power to have receiver, exporter, and the way to manipulate data via the sampling policies. So these are the parts of it. Now, this is where the code is. Let's go to the demo. So, first of all, the consume service is the board API. For the Quarkus apps, if you are interested how they were generated with Java 17, by the way. And the extensions used were REST Easy. It was a REST Easy Classic, if I'm not mistaken. On this one. I also needed a health check for that. The extensions I mentioned earlier. And of course, we need OpenTelemetry. So for the OpenTelemetry, I didn't use the Quarkus OpenTelemetry one. I used directly the exporter for Jaeger. You can also have the exporter to OTLP. So if you don't want to use Jaeger at all, you can go ahead only with the collector and that's it. But in this case, I wanted to use Jaeger. And then, of course, for Prometheus, I use micrometer registry Prometheus part. Also for, if you're going to look into the code, you're going to see that I'm using OpenAPI to observe my API. And I have put everything to the native mode using Jib. And, well, that's it. So this is pretty much the ingredients I had for my microservices. If we're going to the part of their deployment, so I deployed them in Cube. In Developer Sandbox. And if I'm connecting these, I'm sending, and everything is going fine, and requests are being received, so everything is moving really, really nice. If I'm inspecting now in Jaeger what happened, I'll have some things captured there. So let's look a little at the hobby, find some traces, and we can see that a few seconds ago there were some traces happening to it. And of course, I think it was send request. That I was looking for. So this is the normal way of working where my traces traversed the two microservices pretty nice. So I went to send the request from the front end, getting to the activity, calling the activity endpoint, now getting to the cold service, the other microservice, and getting some data. This is the nice part of working with it. So it's the best case scenario. However, just for you to know, the Jaeger configuration that you see here is being configured with a sampling strategy as following. So for this one, I used For the activity microservice, the probabilistic type of strategy, I've done this for Jagger. So with OpenTelemetry, you have two options. You can either go with a batch sampling, and then you're configuring Jagger, I mean the exporter, the receiver, to have a strategy, or you're using this the sampling, the Taylor sampling that I was talking about earlier, and then you don't need these anymore. So you don't have to like use them simultaneously, otherwise you're going to get some mixed responses. Then for service type, for hobby, for the front end, I used rate limiting. So there's another way to like get the sampling of the traces. And for the others that might come for my service in the future, for my for my configuration, it's going to be type constant 1. What this type means is that it will sample everything. In the best case scenarios, when working in production, the advice would be to use either a probabilistic rate limiting, and there's one more called remote. The reason being is that, again, you don't want to oversample and sample too much of it. So these two are just making sure that you're like sampling 8 out of 10 requests, which is a little bit too much, but just for the sake of the example, it's like configured like this. And of course, the rate limiting one is just using a different type of strategy for assessing how many of these things should be kept. At the level of each of the application, because you've seen that I have more operations listed here. Within the operations, I'm also like exporting the information about the health and how healthy the application is, how much time it took for the health to be assessed, and so on, which is again very important to know how much time it took to assess health overall. And yes, if going back here to the hobby, there are a few configurations made for the consumption. So first of all, the OTLP endpoint for production mode is OTel collector. You'll find instructions on how to deploy all this in the sandbox and how to like recreate them. But if you feel that you don't like working with Kubernetes in this case, there's also Docker compose.yaml that is having the same construction to replicate all this. So I really took my time to prepare this part for the sampling strategies and everything so that you can work even on your local if you don't have a Kubernetes installed. Then, okay, we're getting some information. This is for like putting our application into the native way. And for the metrics part, I just binded what I needed. Another good thing that I wanted to know about is like to know the metrics for the JVM performance, the runtime performance, of course, and of course to know how my HTTP requests, client-side, server-side are working. Furthermore, for OpenTelemetry, I chose the propagators to trace the context, the baggage, and of course, Jagger. I had added Jagger as I'm like having Jagger as the receiver and exporter so that I'm being able to trace from the collector towards Jagger, and that would be aware of. Next, what would be nice is to like put the sampling strategy. So there's a way to have the sampling strategy done. If you're going with Jagger with the sampling strategies as I showed you earlier, so you configure sampling strategies for Jagger, you can use the ratio tracing sampler and configure the ratio for that one. If you're not going with Jagger configurations and you're going with the Taylor sampling from the OpenTelemetry collector, then these do not need to be configured. Secondly, we need a way to like say that we're going to trace some resource attributes, and because I'm also exporting my endpoints regarding health and regarding metrics, I said to suppress non-application URIs to false so that I can export that information as well. Furthermore, let's trace some data and see how we can trace data without affecting the context itself. Because I told you that you can use custom headers to like debug. And how we can do that? Well, I have one of my custom headers, and I can just debug without affecting my SLOs, for example, for activity. And I can do that by going here and say curl and add -h, my custom header, sorry, -h, trace debug ID, and say here a local. Now my endpoint, and maybe it would be good to like add activity to this. I hope that it's the right endpoint for it. Yes, activity. So let's trace this one. Okay, I get the response and everything's fine. What you see here with the trace debug ID, if I'm going to the Jaeger UI and going to activity and activity myself, it didn't record it yet. Interesting. One sec. Oh, a few seconds ago. Okay. If I'm going to my span, not the metrics one, the one for it didn't record it. One moment, please. Sorry about this. Let me try with another endpoint. Okay, let me try with a troubled one. Clear. Activity type and say busy work for this one. Let's see what's going on. Okay, make 2 requests just for the sake of it. Okay. So now I get this error on this one. Now if I'm looking to the tags that I'm having here, and if I'm looking to the flags that I have, the tags that were attached to it, I see my trace debug ID to local as well. Now I can use this one so that I can escape these kind of debug traces and calls that I'm doing to my services, so that I'm not counting them against the failed parts of my application. So if this endpoint is failing, this one, I will not take them into account in my counting thanks to this kind of debug flag. So this is one way to avoid affecting your end SLOs and not having that there. Now, if you're wondering where the trace debug ID is coming, this is not magic happening. The way I've implemented this is by implementing the container request filter and adding an attribute to my current span. So this trace debug ID is set here. It can be overridden with any kind of flag that you want. And what is happening is that when my request coming from a browser, coming from from a curl that is using this flag, then when this is happening, is attaching to it automatically this part, so it's present there, this attribute, so that it can be recorded. This is a much more cleaner way to work with sampling. And also, based on the fact that you're doing this attribute, when you're tailoring your sampling with OpenTelemetry, by the way, not just with Jagger, you can also specify this value, like to look only specific for this one, or to do not look after this one when it's there. So this is how you can do it, like for Java point of view, like attaching something only for debug and just looking over it when you need it. And this is how you can find the code. So it's just annotated with the provider, and is using the container request filter from JAX-RS. So it's plain Java, but a little bit customized so that it can work as expected. That's one way on how to debug things. But if you're looking here, I'm going to go back. And we're seeing that we can also debug thanks to the part that's set to error, so that we know that there's an error and there's a status code. So thanks to the errors, we can also trim this in Jagger and say error equals true. Now, how this recording of errors is happening when you're using OpenTelemetry? Going back to my hobby resource, and if I'm looking to my timeout, which I have invoked earlier with busy work, a few things are missing because I want to code this together with you. So how do we record these kind of special situations when it comes to OpenTelemetry? Some of you might find this familiar if you work with open tracing. It's slightly different. The way that you can do this is by looking over the timeouts to the span, the current span that exists, and maybe you want to start a new one, but you're attaching it to the parent. You start the span, then you're putting the span in the current context, and then you can add a few more things to it. So for example, you can add the span dot set attribute, and you can put timeout, and add the value exec. Then you can also, when you're catching the exception, you should know that error to true, by the way, was not just magically happening. It was span.set attribute. This was not the attribute there, but you can put another one if you want and say unexpected maybe. And then span.status, because that's how you get the error actually, and say status dot, no, not this one, status dot error. And then, and say something wrong happened. But I think the most important thing that you should be aware of is that you should record the exception that's going on there. So you can record this exception and pass it further. And then you can end and cannot set the span after this call anymore and end the situation. So you can do this and trace the errors via this one as well. But when it comes to debugging and just making sure you're not affecting the current samples that you're having, you can use the trick with the extra header and making sure that that one is not being tracked by your tools for the metrics and other dashboards and so on. That's one way. The next one I was going to bring to your attention is, looking at the OpenTelemetry config, because we talked about tail sampling earlier, and we should look at how we can do tail sampling also with OpenTelemetry. Well, tail sampling works as follows. You can have policies, so I just put a latency policy, status code policy for error. By the way, if you're wondering where the error is, this error from here, this one that I'm looking at. And of course, for OK. And then I'm also looking for the policy for certain keys, for certain attributes. So you can see one here for alarm and unexpected. And if I'm looking to this one, attribute alarm and unexpected. So my policies can follow only certain attributes or only certain error codes so that I'm not, again, oversampling too much when I am working in production. Furthermore, if we're to look at these parts, maybe it would be good to have an idea on, I don't know, what's the impact over the metrics, right? So I put some queries that can be useful for you when you're working with distributed tracing, and so you can connect certain things. So the Prometheus that I have installed, and where the OpenTelemetry is sending some information as well, I can go and say HTTP server requests max, for example, and I can see how many requests happened and what were their status and so on in time, based on each instance and activity and everything else. And I can observe those, what's going on with them and so on. Furthermore, I can make an average over time of things that didn't work as expected, and you have the query in there. So in the last hour, the average over time over the status code, that is 504, and then you can choose whatever you want, 200 and so on. So if your last hour sampled every 5 minutes, you can see that there were some 504s happening, and that's the average over time. So you can corroborate these metrics with what happened in your trace. If you're wondering where the status came from, it came from this nice UI. It says here, status code 504. So you can connect your metrics to what happened with you in your traces. Furthermore, if you're wanting to get even more insights, for example, about caching, because you can have information about caching and how caching has behaved, how many cache hits were there, and so on. You can still have those informations. Also, again, trace them really nicely with Prometheus. So you can query the cache hit ratio, for example, in Prometheus, and we can simulate that using a tool like Hey. So I'm gonna simulate, there's a small load of 20 requests coming from 10 concurrent users to my activity sandbox. Let me just clear this a bit so that we get some misbehaving situation. And we can then afterwards inspect that ratio and look over it and see what happened. Now this one is, sorry, and let me make this better. So if I'm just putting just the last minute because that's when we have done the big cache hit, we can calculate these parts and observe what's happened to our app. So there was almost no cache hit, and then when Hey has done those requests, then you can see a spike in those requests. You can use this kind of queries also for the miss. I don't know if we have any miss parts. Okay, we have some miss parts for the activity. By the way, if you're wondering where the name of the cache is coming, it's configured in the application with the name of activity in the configuration properties, and that's how I got it from there. Now, this is a very nice way, you can look into collaborating all these informations from tracing to the metrics and stick them together and understand better how your application has behaved. Furthermore, you can also look into these at the level of Grafana, for example, with the nice dashboards, and you can filter based on these parts there as well. But as seen earlier, you can also use only these tools, and it will be more than enough. Cool. So this is where you can find the code for the app. So you find all the code there for the 2 apps and Kubernetes part and the Docker Compose and everything. So all the sampling strategies and everything there, and how to work with it. There's a couple of things that maybe you would like to look into more. So there are more resources if you're interested in Quarkus. This is how you can connect with the Quarkus team. And of course, you can also download some books. By the way, there are some books at the Red Hat booth as well, but you can get for free. And you can download and look at the Quarkus cheat sheet for more things that you can do with Quarkus. That was it from my side. If you have any questions, please please ask me. Sorry about this. I have a small trouble with the microphone. Any questions so far, what you've tried from distributed tracing and so on? Okay, no questions. Thank you very much for coming. Enjoy the rest of the conference. And there's another talk of mine together with my friend Rustam here in the front row at 2:20 if you want to join us. It's about misunderstanding cloud native. If you want to join us, we would be happy to see you there as well. If not, enjoy the rest of the conference, and do not forget to stay for the raffle at the end. Thank you.